Okay, so let's explain further on. Nowadays, I like to use the whiteboard to explain things. Not too much PowerPoint. Okay, so now let's start with this. Okay, so you're going to answer question 1.2a, right? But let me explain to you what it means by this word called Baud. Have you come across this word before? No, Baud rate? No. Okay, what it means, this word Baud, right? It means how many bits per second. For example, right, sometimes you may come across this word. Okay, you may be surprised later on. Okay, now let's say if I tell you, hey, I'm transmitting at this rate. Okay, Baud, it means that I'm actually sending information at these bits per second. Very, very fast. Quite fast. It's not the fastest though. Okay, 2,400 bits every second. 1 second you transmit 2,400 bits. Bits means 0 or 1. Okay, when we say bits, okay, it means logic 0 or logic 1. Okay, that's what we mean. Okay, so that is 1 bit. Okay, so if I say you are transmitting at 2,400 baud, means that it's 2,400 bits per second. Okay, now I want to go through you the other thing. So in general, right, your data can be 7 or 8 data bits. Okay, so when you transmit, usually it's either in 7 bits or 8 bits data. Talking about data here. Alright. Now, so okay. So now before you do further things, right? Okay, what I need you to do is to mark out this on your lab sheet, right? You see, trying to help you on your lab. So you see this little circle thing, right? Okay, now what it wants you to do is to put in the ones or the zeros inside. So for instance, there are many of those, right? There are many circles here. Now I say you want to transmit the character B. Okay, let's start with this one. Okay, what is B? Can you all help me? What is the binary pattern for B? Can you all help me? Give me in LSB first, okay? MSB. Okay, so I want the least significant bit first. There are 8 bits, because it says 8. Can one of you help me? Maybe Gabriel? What is the binary pattern? Binary.
Oh, binary.
Give me LSB first, okay?
0, 1, 0, 0,
0, wait, not too fast. 0, 1, 0, 0.
Then another 0.
So many, 0, 0. Is it right? Then another 2 more bits.
Then 1, 0.
1, 0. Is it correct? Can you maybe just confirm correct? Okay, so this is the this one is the MSB. This one is the LSB, right? For this, thanks for that. Okay, bro. So B, right? Okay. Now I'm going to transmit this information. But before, as I say, before I transmit this data, right? So I'm going to put the data bits here. So 0, 1 is 0, 0, then 2 more 0, right? And then 1, 0 here. Okay. Now what you need to do is to indicate for me. Okay, help me write down this on your paper. Okay. Of course you have to indicate this LSB, MSB. Right? Can you please do this first? Write it down. It's shown over here. But that's not the end of the story, because, as I say, we need to include the other bits of information, right? So we need a start bit. So in fact, they never tell you what is the start bit, right? They say there's one stop bit. Now your stop bit can be 0 or 1. Start, stop, okay, bits, right? You can define anything you like. I can, maybe if I put my start as 0, then my stop will be 1, or vice versa. Up to you to define. So if my start bit is 0, then my stop bit is 1, for example. If you want your start bit to be 1, then your stop bit is 0. Vice versa, you know what I mean? Opposite. So let's say, for example, I assume, say they say they got one stop bit, right? So maybe I go for the first one. I want my stop bit to be 1. Okay, so I'll put like that. Now before the stop bit, there's one thing. There's this thing called the parity bit. Sorry. So this is the stop bit 1 here. But there's another bit here called the parity. I'll explain to you in a short moment. This one. This thing called the parity. Usually denoted by the letter P. Okay, I have the letter P. But I'll just put a box first. Just leave it blank first. Then I will have a stop bit, right? Start bit. Which in this case is here. Then I'll call this start. Is that okay? Can you do this first? Then I'll explain to you later on what is this parity bit. Okay, so you write it inside your notes here, your lab sheet, read down. You just leave this one blank first. Okay? Here, we'll revisit this parity bit again, this P bit, what I call P. Parity or short form P. Is understood? P for parity. Okay. So far so good, So far so good. Can I erase this? Can I? Maybe I'm recording, I'll upload this video into the YouTube so you can see. Okay, now let me explain to you the next thing called the parity bit. This one quite important. Okay, what is parity? Now imagine, right, you have a case, let's say I got two PC talking to each other. Two PC. Okay, call this PC 1. This one 1, this one 2. Okay, so I want to talk to this guy because they are communicating, right? Now, let's say, right, because the communication is two-way. Okay, now before they can start to talk to each other, and they also call communicate with each other, they want to send bits, right? One to the other. That means actually what they are doing, they are sending bits, imagine they are talking to each other. But they are sending communication bits to each other. It could be data, it could be some stuff. Okay. Now, before they can talk to each other, right, they need to agree on this error checking. Now, at your poly level, what you are learning is very basic stuff. This is the error checking, so-called protocol. There's some protocol. This one parity is the simplest. It's only it does one bit check, one bit error checking. Okay. Now there are more complex one which is not covered in your syllabus. There are things like CRC, Hamming code and stuff. CRC error checking, cyclic redundancy check and others. Okay, now you do it at another level. Okay, but what is error checking? Okay, now very simple to explain is this. Now let's say for example you are supposed to meet me, right? Let's say I'm supposed to meet you for a movie, let's say. Okay, I need to tell you several information before we can meet, right? I need to tell you the where to meet, what time to meet, right? We standard. Before, if not I just say we meet, but when. Okay? So same thing, before these two machines can talk to each other, you need to establish what is the checking protocol you want to use. So they need to tell me parity bit. What is the parity checking? Error checking. Now for error checking parity bits, there are only two types. Very simply, parity got odd or even. Okay, odd or even. Okay, either this or this. Very simply. Okay, now what does it mean? For example, okay, if I transmit a stream of data, I'm using this example here. Let's use this example, the data that we are sending B, right? Okay, now we are sending this amount of data, 8 bits, right? Okay, I'm going to send this data to this machine. Okay. Now, but we know that when you transmit anything, hey, have you all played a game before? Before I ask you, have you all played this game whereby you all sit in one big circle, then this guy will start to whisper right at the beginning. Somebody pass you a note, or you're supposed to read this note. So then you will whisper to the next person. So this person will carry the message and then tell the next person. Yeah. So what happens? So what happens when it comes to the end? Or the message go don't know what is it. From beginning like that, become something else, right? That's a little game that you play. So you can see that the information can be distorted. Same thing. When you transmit something, along the way here, maybe got, well, I don't know, it can be anything. It could be some what do you call that? Interruption or something. Okay, so you may actually distort. What I call distortion. Okay, maybe the machine drilling and powering somewhere, and vibration, and the signal, so the voltage spike. Okay, so in case, instead of receiving this, okay, this fella come here, it's something else. That's quite unfavorable, right? We don't want that, right? Okay, say maybe I transmit this, let's say. Okay, at the end, when you come to here, your data already corrupted. Maybe the word is corrupted. Okay, it can be any of these bits here. Maybe I just put maybe this is the bit. Okay. 1, 0. Okay. Now, but you do not know, right? Now this one, because I'm telling you now, that's why you can see. Okay, there's one bit error. This is the error, right? Agreed? But the original data is supposed to be this. But along the way, don't know, something happened. Data come out here. So when you receive this data, how does it know? There's an error. How does it know? Anyway, to check. The only way for this one bit error thing, what called a parity bit, is you actually have an error checking bit here, which is here. Okay, now this is called the one parity bit P. Now before you have the establish this, you must determine first what is the parity you want to use. Is it odd or even? Okay, now let me give you an easy example. Let's say it's an odd parity. Maybe the first case. First case, okay, we say odd parity. Okay, now when you transmit this, before you transmit, we agree first that both sides agree. Okay, we are going to use an odd parity. But what does odd parity do? What does it mean? Now, before you transmit this data, remember you got to add the P parity bit, right? Now, we are going to say that, hey, odd parity means you count the number of ones. Physically count how many ones. How many ones are here? 1 here and 1 here, right? So 2, right? 2 is an even number, right? Right, but we say odd, so what do? We pack another bit inside. We purposely put another bit to make it odd. So how? Is it 1 or 0? What do you think? To make this whole data here to here, this 8 data bit plus the parity, the whole string here is odd number. So we pack a 1 to it. Okay, this is called odd parity. Okay, you count the number of ones physically, how many ones are here, then you make this whole thing odd. Because we say odd, as an example, then we transmit this thing out. So that means there are, just repeat again, so there are 1 1 here, right? There are 2 ones here, but 2 ones, it means it's an even number. So I need to pack another 1 here to make it 3. So it's an odd number. Then I transmit. Okay, understand? Yes.
It's like 2 bits change, right?
Yeah.
The one becomes 0 then.
2 bit change meaning? Yeah. Okay. Good question. What do you mean by 2 bit change? You mean
like while transmitting, right? 2 bits change.
Okay. Good question. Okay, I'll answer that question. This is a question some student will ask. Okay, but that's a very good question. Okay, I'll come back to you. Let's look at this first. I'll address your query. Now, when you transmit this, right? Now the parity bit will stay. Okay. Now when you transmit this data, right? Now, just now we say we purposely have an error. If there was no error, okay, if right in the beginning if you transmit it without any error, okay, if I put a 0 back, this is the original data, right? Same thing, no change. 01000010. Okay. What the receiver do is that it will count. After you receive the data packet, it will count 1, 1 plus this one 3, odd, fine, cool. This data seems to have no error. Accepted. Okay, same thing you will check for odd numbers. But let's say this one got error. Xiaojun, morning sir. Too late. Okay. So when the receiver receives this, he will count. There's an error, right? 1, 2, 3, 8 plus this one 4. It's an even number. Something is wrong. You see what I mean? When he count, the thing is even already. The number become even here. Something is wrong. So what does this machine tell the other machine? Can you please resend again the last information? This packet got problem. Do you see the thing? Okay, so they have to determine, they have to count and then to check whether is it odd. But initially they already agree, right? Right from the very start, they agree that it must be odd. Let's say odd. Okay, we agree really odd. Do you understand? Okay, so when you transmit, then you check 1 bit. But just now the question is very good. If there's a 2-bit error, this speller cannot handle. That means you cannot use parity. It's a good question. Okay, if let's say you got 2 bits error. Good question. 2 bits error. 2 bits. Because if it's 2-bit chain, right? You count 1, 2, 3, 4, 5. 5 is still odd. You may take it that it's okay, right? The receiver type may think that it's okay or odd. But actually there's an error, right? So for parity bit checking, 2-bit change it cannot handle. So they will not use this for a 2-bit error. They have to use other techniques. Okay, to answer your curiosity, 2-bit chain cannot handle, no way. Okay, only can handle 1-bit error. Okay, so let me revert back to here. Okay, 1 bit only. Okay, very primitive, but no choice. Okay, this one is a parity bit. You must go resort to other techniques. Okay, do you understand? Odd parity. So likewise, if it's an even parity, later I'll give you another example. It's the same thing. You just count the number of ones. If it's even, then you make sure that when this one is even, and then you pack this bit to become odd or even. Let's say even, then you add it. So this parity bit is not always 1. Remember, it can be varied. Can be 0, can be 1, depending on this thing. Okay. Now, can you tell me what is the parity bit for this one? Did they mention? Okay, even, right? They say even parity. The same question. Can you refer back to page 2? Okay, even parity, right? You read the question carefully. So what do you think this parity bit should be? Even. What do you think this bit is? Count, very simple. 1, 2. Right? Don't count the, don't include the start stop bit. Start stop bit not included. You only count the data bits only. So this one don't count. Don't count this one. Don't count this one. Start stop bit is fixed one. It's the data bits plus the parity bit. So in this case, your bit will be, if it's even, right? So it should be 0, correct? Then I'll transmit. I'll package it, then I'll transmit out. So 1 and 1 is an even number already. So I put a 0 to it. It's okay. So it's still even 2, right? Even parity transmit. Okay, so your answer should be as according to here. Any question? Okay, so far so good. Anything you don't understand? If not, you can look at the next one on page 3, question 1.2c. Okay, so same thing. I need you to fill in the frame structure and put in on or off. Okay, and so on.